My live testing. Why is my display not seeing? I guess I am live now. Yeah, it's still loading. I don't think so. Yeah. Oh, hello everyone. Welcome to the stream. And I know I wasn't really hinting on doing anything like this. And I haven't actually uploaded a lot. Like I uploaded my last video like 2 weeks ago, but the video before that was like 4 months ago or something. So yeah, I didn't actually get a chance to upload a lot of videos. Uh, I've been pretty busy. So yeah, in this video we're gonna be doing something cool. So I found this paper on the internet. It's a very, it's not a very popular paper. I guess it has like just 2 citations or something. It's also pretty recent. And so I figured we'd implement this paper because I figured it was a good paper. I mean, I don't know if this is gonna work or not because this paper doesn't have enough citations for me to kind of gauge if it works. I mean, it is from a pretty reliable source, so I'm not doubting its credibility too much. But I don't know if this is gonna work or not. But yeah, I don't even know if we're gonna be able to code this out. But yeah, so this is the goal for this, and maybe like the next few streams or videos is to try to implement this. Don't think that I'll be doing all of this on camera. There's a decent enough chance I end up implementing this stuff off camera because I can't stream and I want to get this thing done. So I've already gone through the paper a little bit, highlighted some important stuff. Majorly because I didn't want to do that on stream. I thought it was kind of boring, so to do it on stream, so I figured I'd do it off camera and then we can maybe kind of jump into the code directly on stream. Don't worry, I'll kind of walk you through the paper so you have a decent understanding of what we're trying to do here. So what we're trying to build is a modality aware transformer. If you don't know what that means, I didn't before I read this. But basically, what a modality aware transformer is I mean, it's just a very fancy way of saying that this transformer can take data coming from different modalities and it is able to kind of nicely talk to each of the modality and extrapolate all the important features and hopefully come up with a good prediction. So in this video we're gonna try to maybe start, I don't know what we're gonna do in this video in terms of like are we gonna do dataset building and pre-processing, or are we gonna do layers. There are a bunch of ways we can start out with this. Like we can start with layers and then do the dataset stuff, or we can do the dataset stuff and then do the layers. But I think I'll start with the I think I should start with the dataset, majorly because the layers, if you take a look at this, you'll see that a large chunk of it is just the normal transformer. There are a few differences from a transformer, like this intermodal and intermodal attention, and then this feature level attention. But other than that, you can kind of see it's just like a transformer. It's not much more different from that. So I believe we can do like data processing today and maybe do some other stuff in the next video, whenever that may be. So yeah, let's actually get started with this. I'm gonna do all of this in a Jupyter notebook or collab or something. I think I'll do it in the VS Code's Jupyter notebook just because it's good and looks pretty well. So yeah, I'll just make a directory which is gonna be modality aware. Yeah, I didn't spell it correctly. Oops. Alright. CD. Alright. I'll just open this up in Visual Studio Code and we can get started with this. Alright, so we're gonna do this for equities. So we're gonna do some equity prediction using this. And I don't know, like these guys were using this for interest rate prediction, which is also a good thing. Uh, but I don't really know that much about interest rate prediction, so I don't think I can make something good. So I'll do equities because equities was just more interesting and fun to work with. Interest rates, it's a little bit boring. Very important, but kind of boring. So I'll just make a new main.ipynb file. If you don't have like this Jupyter extension, I'd recommend you go ahead and download it because it's good. This kind of sucks for some reason. So I haven't used OBS in like 5 months at this point. The video that you saw for the physics informed neural nets was actually shot in QuickTime, and I actually have also shot like 5 or 6 other videos that I haven't uploaded yet on QuickTime. So I haven't used OBS in quite a while. So my laptop's kind of adjusting to that. I don't know why this isn't loading up. I mean, I do have a Jupyter notebook. I can maybe work on that too. It's no big deal. And I believe that's what I'm gonna have to end up doing because I don't think. Yeah, there we go. Okay, I believe this should work now. Change the language to Python. You have like a whole bunch of languages you can choose. And everything is just lagging. Not what I expected. Python. There we go. Damn, it's slow. I don't know if I want to work on this because it's so bad, it's so laggy. Like, I literally just saved a file. It's taking like, what, 10 seconds to actually save the damn file, which kind of sucks. So, okay, let's just start out. So, what we need to do first is we need to actually collect the data. Now, from what I know, there aren't any good data sources on the internet that kind of do this thing for us and like just give us financial data with the news and everything. There are a few APIs, but all of them are paid, and I don't want to sign up for a free trial right now, so I'm not going to do that. There's one API that is free. It's not a very reliable API, but I mean, it is free, so for now, we're going to roll with just that, which is just the Yahoo Finance API. It's actually not the Yahoo Finance API, it's actually the Yahoo Fin API. So we use that. I'm also just going to shut this thing down because it's way too laggy. Like, you can literally see my Chrome isn't loading because of it. Like, you can literally see it's so laggy. So I'm gonna use this thing known as Yahoo Fin. I think it's this one. This is the documentation for it. I'm not gonna open that up right now because again, this documentation, it's a very buggy page, so I don't really like it. So I won't open it unless I have to, right? So what I'm gonna do now is I'm just gonna open this up in a Jupyter Lab, so we can work with it on that. Alright, there we go. Okay, so I'll just walk you guys through the paper. So just take a look at this. Basically, the way this model works is you have your transformer encoder, and the way the encoder works is instead of just having this one block that is stacked up n times, you have these two blocks. One of the blocks has a lot of text or like secondary information. So like for this, you're gonna have information that is like, I don't know, things like the news and stuff like that. And then you have your input, which is your time series data, and then the time series data is basically going to be like your main close prices and stuff like that. And then basically it kind of goes through this goes through this, and then this bit of cross attention between the two. You can see that all we do is we share the queries, we don't share anything else. And after that we kind of, actually no, we don't, do we share the queries? I don't know, have to check. Do we share the queries? Yeah, I believe we do, because you can see that the query thing is sort of uh, like it's yeah, I think we are sharing the queries. Yeah, because you can see we pass in query time series here, and then we pass in query text here. Alright, so let's just get started working on this. So let's just start out with the import. So we're gonna need a couple of libraries for this. So we need torch, we're gonna need, and then we're gonna need pandas, and we're gonna need this. And I'll also just go ahead and import matplotlib. Alright, so let's just start loading in the data. So I'm gonna do this on a particular ticker for now. So I'm gonna do this on the SPY, or let's actually do this on a ticker, like a stock. So let's just do it on Apple or Tesla, whatever you want to pick. I think I'll go with Tesla for now. It's increased a lot, and I believe we should be able to actually get some good news on this after the election results and stuff that came out a little while ago. So we have a ticker. What we need to do is we need to get our df. So we just do si.get data, and I'm gonna get the ticker. Oops. I only really care about the closing prices, so we can just get the close prices. I don't know if I should even convert this to a list, because I don't think I should convert this to a list, to be honest. Also, I'm not sure if we're gonna need numpy or not. We're gonna need sklearn also. I don't know, I haven't imported that. We'll do that later again. So we have our df close. We can convert it to a list for now. Or should we just keep it as a torch tensor right from the beginning? Let's keep it as a tensor. So I'm just gonna run type of close prices, just get a understanding. Yep. And I'll just check that by, oops. Yeah, I think this is kind of what I want. Alright, so we have a tensor of the close prices. Now what I'm gonna do is I'm gonna set some sort of a window, and I'm gonna set it to 60 days, and I kind of want to roll through this window with the closing prices in order to create like, actually, but before we do that, we need to actually scale the close prices from 0 to 1. For this, we're gonna need the sklearn scaler. So sklearn and max scaler. I'm gonna use this. Alright, let's just use this. We don't need to do any of that. I just want the code to define this. Yeah, so we first import it. some conflicting numpy version, but that's alright. Then we define the scalar. Oops. I think I need to specify a feature range in there. I'm not very sure. Feature range. I'm pretty sure I need to specify that. Yeah, but the default is 0 to 1, so I don't think I should care about specifying that. And then I need to do a fit transform on the data. So we can just do those prices equals scalar dot fit. Alright, that should do the scaling. Apparently not. So we're gonna need to do this because I haven't reshaped my array. I don't know why. I always get this error, but I just never really never really deal with it. Alright, let's just get the type of close prices. I don't know if these guys have done any kind of wonky numpy array conversions in there that I haven't asked for. Yeah, like I said. So I have to understand if the zeroth is going to be a tensor or not. Like, is it a numpy array of tensors or anything like that? Wait a minute, I'm not exactly understanding. So if I just get close, alright, so if we just call a torch tensor on this, so torch.tensor, and then you can just do a close prices equals torch.squeeze. You can just squeeze it along the first dimension. Oops. What is it? Oh yeah, I don't remember. Do we just do a close prices dot squeeze? I'm pretty sure. Just do a close prices dot squeeze. So now if I get the close prices dot shape, it is just this one dimensional thing, which is a good thing. So the next thing we need to do is we need to actually set like a period to look at this stuff, and then we need to actually deal with a bunch of other things. So the thing is, there are a couple of things that you need to kind of take into account. So normally the way transformers sort of work is you have some input data, and that input data is always going to be in this form of b by d by c, this kind of a form. So this is batch, this is time, and then this is some sort of an embed dimension. Now we have a b and a t. We have this. We have a batch and a time. The thing that we do not have is a c dimension. We do not have an embed. We don't have this. Now the point is, I don't know if this kind of data is actually fit to be embedded into that kind of a format. Like, textual data I understand why you would want to do that, but for this data I don't understand why you would want to do that. So I don't know how we're gonna deal with that, but yeah, that was just a concern that I'm having. So we'll address that when it comes to that. So we'll set the window to be 30. Basically this means that the time is going to be equal to 30 because we're going to look at it every 30. And now what we want to do is we just want to look at x train. So that's just going to be equal to like a torch.stack. Okay, how do we actually go through and sort of get all the correct values and stuff? Should we do a torch.stack or a torch.cat? I'm not very sure of it. I believe the stack could work because, or maybe the torch.cat will work a bit better. So I'll just look up torch.cat. This will concatenate like different tensors and stuff together. So I believe we can use this. Okay, why on earth am I getting a redirect to some random ass trading platform? So if I do a concat on X, which is a 2 by 3, I end up with a 6 by 3. So this is what we want. Instead that the 2 will be different, and that's alright. So yeah, we're gonna do a cat instead of a stack, and we don't have to specify the dimension, maybe because the dimension is gonna be 0. Yeah, so the dim is 0 from by default, so we don't need to specify that. Really all we need to do is specify the what do you say, the tensor. So the way we define the tensor, I believe, is we can do it as a list comprehension. And how do we do that? So I can say, okay, so we can do something like this. We can say close prices. So I want to start from like the 0th to the 60th, then the 0 to the 30th, then 1 to 31st, and then so basically I want to go from, let's say if I start from 30 with I, then I want to go from I minus window size to I believe that's correct. So I can do something like I minus window to I for I in range window to the length of those prices. I'm not very sure if this is gonna work or not. So if I just run xtrain, I'm not. Let's hope that it works. I don't think that worked. Okay, maybe I need to specify the dimension or something. I don't know. I minus window to I guess I know the error is because we are doing this first for the whole list, and then we are sort of what should we do? Maybe I need to wrap this within like a torch tensor or something. Nah, I don't think that made any difference. Because I can do this very easily, but then it's not gonna look that great, which kind of sucks. Like I can have an X train and stuff, but I can have like an empty X train and an empty Y train. And before I arrange one of those prices, we can do X train dot stack or cat. We can just say X prices, oops, will be close prices I minus window to I, and Y prices equals close prices I. So we can cat the X prices and do the Y train dot cat the Y prices. Alright. Blah 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 blah. That just sucks. This is a very, I don't know. initialize a blank empty tensor in torch, or create or something. I don't know. Wait, what? We actually need to do that. So you need to specify so much of stuff. Are you crazy? Nah, so it literally just returns average value, like random values. It doesn't actually return an empty tensor. We want like an empty tensor. So maybe we can just initialize it using zeros. So we can just do a zeros like. I don't know how to spell zeros to be honest. And then over here instead of cat, we can just say x chain I, y chain I. But then even that won't work because it'll start from the window. And the length on this one is a little different. Oh, for God's sake, this just sucks. Yeah, I think the only option I have at this point is to just make them like empty lists. I hate this code, I really do, believe me. But I seriously just don't find any way out of this thing. Because if you look at this, the problem is, if you look at X-Train now, it's just a very bad data set. I'm sorry, bad kind of a. It's not a very good way of representing data because it's like a list of tensors instead of a tensor. I don't like that. Because I can't directly convert this to a tensor itself now. So I believe the only real way that I can deal with this is just do a dot detach. And then we can just kind of make this a list. Maybe I can just wait a minute. If I just do t equals torch dot ones 3 t, I just do list. Wait a minute, what? Oh, I forgot to do that. Cool, so we can do something like that. Or we can just check. Oh, so there is a dot to list function. I'm assuming it's not gonna be a. I hope it's a like a fast way to do stuff. Because a lot of the times Torch provides you with these things, but since people with actual experience don't use them, they usually aren't gonna be that quick to use. Well, apparently it is. So we have an X train now, so we can just do X train. I need to fix this code, I know, and we'll do that, but I'll do that once I have everything in place. So what I have now I'll make a comment. What we have is we have a shape which is matching b by t, batch by time, but what we need is we need a channel dimension b by d by c. Because if you look at this, and you look at the shapes that they kind of expect, you look at this. So the modalities and the way you actually shape the query keys and values is basically the same way you do stuff in like a normal transformer. From what I can see, because if you look at this, you kind of get a decent idea. Other than that, I don't really find a lot of stuff on this because the paper doesn't really talk about like they do talk about the fact that they are implementing this, but I tried finding this and I couldn't. I'll still try it out once because uh, it would be a little bit helpful for us to kind of understand if what kind of data sets they kind of what kind of uh, what kind of shapes they kind of really want. So a bunch of these. I don't think this one is the thing. This is a cool repository. Yeah, this is a pretty cool repository. Like there are literally so many just transformers that sort of do this stuff. Damn. I mean, look, a lot of the times these papers they are basically just 95% transformers and then it's like just 1% of actual stuff. Like new material. But whatever. So yeah, this is something I actually wanted to try out also. I definitely want to try this thing out. I didn't know that there was a paper on it. Nah, I'll try this out. So after this, I might just give a shot at Kalmogre or neural networks. But yeah. So what we have is this. So our next step is something that is sort of, I would say, up to debate at this point. Should we encode this into an embedding or should we not? Because if we embed this, like I believe we'll lose out on the numeric nature of the data. But if we don't encode this, then we aren't going to be able to actually create a attention block. For now, let's just keep it at this. Like, I mean, frankly speaking, the encoding part shouldn't really take that long. It's gonna take like a 2 or 3 lines of code. Because even if you look at this, how exactly would you even encode this, right? It doesn't make a lot of sense the way you want to encode this. Because what we have is we have a bunch of prices. So when you're gonna work on an encode this, you're gonna need a vocab size, right? What kind of a vocab size would you set in the embedding table? Since you don't know what vocab size it is gonna be, because you're gonna get any price. This is like a continuous thing, so this can take up any continuous value. It's not something like a text generation thing that you can only take up like letters from A through Z. This can take anything up, so we can't exactly deal with this in that way. from what I can see, I don't see, like, first off, I don't know what they are dealing with this way. Because in the paper, the first thing is they don't actually provide, like, they're literally repeating some stuff here and there again. It's almost as if they're trying to prove that they have made, like, they have actually made something new in this paper. And yeah, to an extent that they have, but it's actually it's a small update. Like, my main problem with this is that they talked about how they had actually coded this, but as far as I know, they didn't actually provide any GitHub repositories. Because if you look at this, they talk about how they did it on PyTorch or something somewhere in the paper, but then yeah, oh yeah, in the implementation details. So if you check this out, you can literally see that they they kind of talked about it. You can also see that it's a very rudimentary implementation detail, and I can see that, like, come on, man, they haven't actually given the code. They're talking about how they've used code and how they've actually coded this out, but then they haven't actually provided the code. The fact of the matter is, it is not some insanely highly cited paper that I can find an implementation for it. So the first thing I need to figure out is exactly how I can even deal with this thing. I need to just deal with that, because from what I can see over here, if we look at the for this, if we look at the query key and I value dimension, there's this L variable. I don't know what the L variable is. Lengths of the queries, keys, and values in the ith data modality. What do you mean by length? So for the length, we could just set it equal to 30. Right. We could just do that. I mean, theoretically speaking, I don't think that should be a problem. Because to be honest, I mean, it makes sense to have that, right? Because you can't exactly embed this data. We can only scale it up or down. So the in this case, the modality aware transformer will have qk of shape and pq and so on, where L is the length of the qk or v for the data modality. Thus, in this case, L should be equal to T should be equal to 30. Probably. Not very confident about this line that I've written, but probably. So if that's the case, then we have the numeric data, or whatever you call it, sorted. What we need is textual data. Textual data we can get. We can get it. We can get it through Yahoo Finance. So there's a updates and news section on this. I don't know where. Okay, there seems to be less battery on my laptop. Yeah, so this is what we want, the news module. So we import that. Then we get some news. And equals. And we specify our picker and print out. So we get some news. We got a lot of news. So the way we can do this is we can just trim, like we. So what exactly do we want in the news? So I could have the entire value and stuff, but I'm not gonna do that because that kind of sucks. And obviously the published date also matters quite a bit. Because if you look at like the last news, nah, okay, so all of this was like published on the same day, so that doesn't matter a lot. So what we can do is we can just get the summary, so news JSON, and then we can just get news summary. So we can just get news JSON and summary. Oops, I'll just print this out, and then we can try to index into it. So we have, let's say I do something like news JSON 0, and then we print that out. So we have this news summary. So we can do something like news summaries. I don't know if I'm spelling it correctly. And then we can just do a for I in range len of news JSON. And we can just, instead of doing this, we can do a news summaries dot append. Yeah, and I don't want to do this in like these two sort of lines, so you can just do this I for I in range then of news JSON. Yeah, cool. So we get some news summaries, which is pretty nice, and it obviously doesn't work because something breaks every time. Something has to break every time. I don't know. Oh, oops, very very stupid error. Sort of expected that I would make something. Now it works. Cool. I'm gonna get rid of this thing because it just sort of comes in the middle and I don't care. So this is what we have. We have a bunch of news. Now you can see, from what I can see over here, there are a couple of these summaries that get quite long, which sucks. And that we need to deal with that, and then there are a few other things that we also need to deal with. So one of the things we need to deal with is adding like start tokens and padding tokens and stuff like that. So we need like a padding token, we need a start token, we need an end token, which kind of sucks because we're gonna have to do so much of stuff. But yeah, or we can just have like a end of sentence token, which kind of, or end of line token or something like that. We can have something similar to that too. So we can just define like a start token, which you can just say start, end token, and oops, padding token equals pad. Now we need to actually do the thing. So start token and end token are pretty simple to add. Just a second guys, I'll have to put my charger really quick. Yeah, right, I'm back. I didn't want the laptop to just crash with my stream on because of insufficient battery. Alright, so what I need to do now is just kind of add a start token. What I can also have is sort of like a max len, because if you look at this, some of these news articles are pretty long. I don't like this because I don't like a news article that's this long. Like it's a summary, but it kind of sucks because there's a chance that a large chunk of this is sort of important, and so if I just cut this short, then I'm potentially just, you know, not actually encoding the context in there. But the fact of the matter is, so obviously the more better approach to doing this would be to have some sort of a detector that checks whether a news article should be removed or not or something like that, but I'm not going to do that. uh, we can set sort of a max limit on characters because there's no way on earth that I'm going to have such a long thing and then have such short sentences also. For now we can just do that just because it saves some time, but that just really sucks. I don't think I'm gonna keep that very long. So first I just get the max len. Also I'm not gonna, since I haven't used caps locks for constants, I'm not gonna do that. So now we can just get the max len. So you can see the max len in terms of characters is 1259 characters. So now we also need to tokenize this. Now there are a bunch of ways to do this tokenization. So we can use tick token to do the tokenization, which is a byte pair encoding style of tokenizer. But the problem with tick token is that the way tick token does tokenization, it does it, but I don't think I can actually add special tokens. Oh, apparently I can. So yeah, this is something we might have to do because we need to have some sort of special tokens in tick token, majorly because we need our these tokens. So what we're gonna do is we're gonna do the padding, do the start, do the end, and then we're gonna do the tokenization wherein we specify those as the special tokens. So we have a max len over here, right? So now we can have like a method that just define pad sentences. Oops. So we can just do like sentence max pad len and pad token. If len of sentence equals pad len, or more like not equals pad len, only then I want to do this. Otherwise we can just return the sentence. So if that equals the pad length, I want to do the padding. So first we need to define num pads, which should just be equal to the pad len minus len of sentence. That defines exactly how many number of paddings we need. So then we can just say sentence equals sentence. Actually no, we can just do sentence plus equals sentence. Oh, how do we do this? Yeah, there's no way to do this. There's one way to do this. We can add the pad token, and then we multiply pad token by num pads. So let me show you this. So if I have a string a, and then I do a times 3, I get this triple A. So that's what we are doing. And I need to make this an underscore. And yeah, that I think is it for the pad sentences function. and I think I should call it a sentence for now. So this is actually a really cool function because it's pretty reproducible. Like you can just copy this stuff and use it somewhere else in some other function or something, which is a pretty good thing. So we can then just say padded sentences, and we can just say pad sentence, and we also need to do a couple of other things, right? I just don't want to pad it, I also want to add the special tokens and stuff to it, right? Because even that's kind of important. So what we can do is we can do something like this. We can do start token and end token, and what we're going to do now is something like this. So this doesn't change, but here we can do start token plus sentence plus end token. So yeah, that does increase max length by 2, keep that in mind, but I'm okay with that. So then we can just say padded sentences, which is equals to pad sentence I for I in new summaries. Oops. Oops, I need to specify the other stuff. So that's going to be max length, then we have the pad token, the start token, end token. There we go. So if I print out the padded sentences, cool, this stuff actually works. It's so cool. We have a start, we have an end, and then we have a whole bunch of these pad tokens in there. You can see that it kind of sucks because every single one of these has these pad tokens in there, which kind of sucks. Because only, like, I don't like this. Oh, actually, there's a bit of an issue, maybe. Wait a minute, which? Okay, so this one is the longest. Let's actually set a max length. So yeah, let's do that. So we can just call it max pad length, and I'll hard code that to something for now, to like 300. So yeah, it's much more better. But over here, so what's happening is we aren't padding it correctly because anything over 300 is also getting printed, which we don't want. So what we do now is over here in this whole thing, we kind of do this, and then we only print it up till the pad length plus, nah, not this. So what we do is yeah, I think this should work. Yeah. So basically the reason why I did that is because if I do something like padded sentence is 0 and I get the length, you can see that the length is 313, and I believe that the length is 313 because of these ones also. So like, because this takes up 1 2 3, I guess 5 tokens. Yeah, 5. And then start takes up 6 and 7, so it takes up like a total of 12 tokens. So I don't need to do the plus 1, so it becomes 312, which is exactly what we want. uh, this should be max parallel plus 12 to account for the tokens for start and end. Yeah, nice. uh yeah, I mean, we are pretty much, we are working on a good pace right now. How long have we been going for? I don't know. Whoa, what happened? I figured my laptop just crashed. Something's up with my trackpad. Alright, we've been going for like an hour at this point. So what we need to do now is we need to do the tokenization. So that's what we need to do. So let's just import tick token over here. And now we can do the tokenization. So I don't know how this should work. I could ask ChatGPT to do it, to be honest. But yeah, I'd recommend you use something like tick token. There's also this another tokenization library. I don't remember. I think it was like some Spacey or something like that. Yeah, I think it was Spacey. Yeah, I mean that's a good library for tokenizations. It's a lot different than tick token, and but in certain cases it's better. In certain cases it's worse. But yeah, it's a good library. It's decently documented also, so I don't think it should be a big problem implementing it. But I do believe that the documentation for it is a bit overwhelming, which I don't like, but that's alright. So, what we need to do now is we need to somehow uh, do some sort of. What do we need to do? We need to do this, something like this. If you are changing the set of special tokens, make sure to use a different name. What is this? Like, I don't know exactly which special tokens tick token uses. Because the way it's gonna work is for any token that is just not the special token, it's gonna do like a subword tokenization on it. And for anything that's a special token, it's gonna do like it's gonna consider that as one token. So I'll just ask ChatGPT, maybe it can know. But it was tokenized on. It was tokenized using tick tokens. I'm hopefully it knows. I have a set of special tokens which are, we can just specify all of that stuff also. Just give it everything and then hopefully it works. And oh, why did I press enter? I am using tick token to tokenize a list. Tokenize. Whoa, tokenize. Bro, I know that. Tokenize a list containing normal letters and these special tokens, but and I want tick token to consider these let's go. So we do this. So the reason why we do 100,001 and onwards, because we're using the 100K base. So let's run this and hopefully it works. Okay, get rid of that then. And then, okay, now this is a bit of a moment of truth for me. If I do custom encoder dot encode my padded sentences 0, oops, what do you mean? Wait, what? Encounter text corresponding to disallowed special token. I don't understand. What if I just copy this and paste it here? For the special tokens, I can just pass in my special tokens. Okay, it doesn't work. Let's search HGPT. Oops, what is happening? Alright. Oh, so we need to specify the alarm special. But didn't we literally do that when we had actually... I don't understand. This is just stupid. So I just do that. And for this I just pass in padded sentences 0. And I need the comma. Oh, it actually worked. Damn, that's cool. Print out encoded. And it works. That's so cool. Yay, it works. Yeah, so you can see we have these padding tokens. And then we have the end and the start token. That's so cool. Yay, it works. So now I can just do the same thing but for all the padded sentences. But I can't do that. Yeah, I mean that's not too difficult of a thing. I mean I can just do that really quick. So we can just do encoded sentences. Or more like yeah. Oops. Or maybe encoded sentence. Do that for I And here we can just do I. Make the sentences. Oops. Alright. So now if I get the encoded sentences, it actually works. That is so cool. That is just so cool. It actually works. I'm assuming there are a couple of issues in this because it does this 1003, but then it has these two tokens. Why does it have these two tokens? It shouldn't have those two tokens. Wait a minute, let's just say one. Okay, I'm assuming this one, the first one was just like sort of a anomaly or something. I don't know why it has this token. Split out pretenders. Like, is that the case for all? Like, it's just one token, so I'm not too concerned about it because it's literally just one token. All I'm saying is, why is it showing up as the second last token? Yeah, like, there is a bug, I can tell you that, but it is like a very small bug, you know? And so I'm not really concerned about the bug. Yeah. So now that we have done the tokenization and this, I believe we are done with the data pre-processing. And I mean, it took us like an hour and 7 minutes, which is, it's respectable. I mean, I didn't expect we'd get it done in an hour and 7 minutes. It's a good thing. In the next video, I believe we can start with the model. I think this much of data pre-processing is enough. And now we can actually do the fun stuff. So it's gonna be like much better now. So yeah, in the next video we'll deal with actually making a model and working with it. And I hope you guys will enjoy that process. It's gonna be fun. Like, yeah, this video and this stream was a little bit bland in that way because we weren't really doing anything in terms of like, you know actual model building and like layer making and stuff. But I mean, this stuff is also very important, and I usually put this thing, I let these things slide, and I don't really like doing this stuff, and it always ends up costing me a lot. So I just don't didn't want to do it in this one. So I just figured I'd start with this. So yeah, in the next video, I believe we can finally start, and we'll start out with the feature levels and the intra models. Uh, I'll have to make, like, I don't know. I could. I mean, so the thing about this code is it can be coded in a much easier way if I, let go of the fact that the code should be neat. But if I want the code to be neat, then it'll take much less code. But according to me, the code will be like much more complex. So yeah, I don't really know. Yeah, but I mean, it's gonna be fun because you can see that there's so much stuff, and yeah, like there's a encoder decoder cross attention, then there's this intermodal modal attention, which is sort of a cross attention. Then you have a masked multi-head attention, you have an intramodal attention, intramodal attention. So it's like you have so many attentions. You could either make them all and like make like one attention and then have inheritances of it, or that's probably what we are gonna end up doing. And this stuff is pretty straightforward. Like the feed forward stuff is pretty straightforward. Other than that, the main thing is just the attentions, really. So yeah, that's it for this video, and I hope you enjoyed it. From what I can see, this stuff is pretty much what these guys have also done. So you can see that the textual module for these guys, they have the text embeddings, and then they have some. What is this XTXT? Where have they referred to figure 2? Is to use to represent each text report into a format comparable to time series that can be used along with the time series and modularity. And input to the textual module consists of n text reports collected in the last t steps. We start modeling the sentence by disarranging the text articles into sentences. So, number of sentences are large and varied per time step. Sentences are aggregated to the topic level. For some reason, why on earth are they doing that? I don't think we need to do that. So instead of actually passing in text, they're passing in sentiment scores. I don't know why they're doing it. I don't know, must be some reason. So that means we still need to do stuff because we need to actually get the sentiment scores. I don't know how we're gonna do that, to be honest. I believe I'll just use like an API or something. Maybe they are telling us to use BERT or something. I don't know. I'll maybe use BERT, but I don't want to do that because I don't want to write that much of code extra. I'll just end up using an API for that. Also, because I mean the paper is it's not that well written, at least from what I can see. Maybe it is, and I'm just a noob at reading it, but maybe it isn't because I don't see a lot of the way they've. It's more about the way they've arranged the information. It's not a very reader friendly way of arranging information. It's more like they wanted to deliberately make the paper sound complex. I don't know why they did that. I don't know if it was deliberate or not, but whatever. So yeah, whatever. So that's it for this video, and I hope you enjoyed it. I'm sorry, that's it for the stream, and I hope you enjoyed it. If you did, like and subscribe to the channel, and let me know what else it is that you wanna see. And yeah, we'll continue on with this in the next stream, and hopefully we end up doing something cool. So yeah, I mean, uh, I don't know when the next stream is gonna be, to be honest. I don't know if there is gonna be stream. Maybe I just end up coding this stuff off camera or something like that. So yeah, it's all very like I don't know. It's don't be waiting for stream. I might post or there's a chance that I might not be able to. Mainly because uh, you know streaming takes a lot of time and effort, to be honest, and sometimes I just can't really take out that much of time. So yeah, whatever. So that's it for this video, and if you guys have any suggestions on how we can approach that whole text stuff, the thing that we need to do now, which is the whole extracting sentiment scores and stuff, do let me know because I'm not very sure of the way we can approach it. Like because I mean, there's a lot of subtleties in the way that I think I should approach it. I don't think it's a very good way. So yeah, so that's it for this stream, and I'm saying that for the third time. All right. So bye bye. If I can actually get the stream to end correctly. The stream should stop immediately. How do I stop it from there?